So, all right, fourth hour. Start up here at the top. When I'm in standard form, how do I work on finding the x part of my vertex? That little formula. Negative b over 2a. So here, my x is going to be negative b over 2a. So that would be negative 6 over 2 times negative 1, negative 2. So my x value would end up being 3. Now again, at this point, I have options. I can either get my chart set up here, and I know what the x value is now, and say, okay, I know I'm going to want 2 values that are less and 2 values that are more. So at this point, if I wanted to, I could go ahead and type it in to the calculator and let it do some of the other work for me. It also keeps me from maybe making a mathematical error. Now, I don't want to just draw a sketch. I'm going to want the specific points. So I'd go ahead and I'd hit second graph. If it wants to let me. Second graph. There we go. And again, I'd want to make sure my vertex was in the middle, which it is in this case, because you notice it's symmetrical going each way out from there. And what I could basically do then is I could start working my way. So let's see, 2 was 9, which means 4 will be as well. 5 is 6. And that'll be as well. And then at that point, I just go ahead and graph as far as like building my chart, you mean? These two will always be the same, and these two will always be the same, as far as the y value goes. So it'll kind of save me some time that way too if I was doing it just manually, plugging numbers in. Again, since this is just an equals, we don't have to worry about dotted solid, that craziness. As far as, oh, you mean if I'm doing it on the calculator or if I'm just, okay. I just would type in what the actual equation is, the negative x squared plus 6x plus 1. But I need to know the x value of my vertex first. Because I want to make sure I know where to go in the chart where it's going to be symmetrical. So that's how I just did that. And once I graphed it, I just hit second graph and then I went to the table from there. Did you get negative x squared or did you just have negative x? Okay? So once I get this, now I can just fill in info. 310 was my vertex. If I push this up a little bit, my axis of symmetry, okay, x equals 3. Have to have the x. I will ding you otherwise. Because if I just write 3, that doesn't tell me anything. It could be y equals 3, x equals 3. I don't know what it is, just a point at 3. So you have to make sure on your axis of symmetry to have the x equals part in. That's actually the one that takes the longest, surprisingly enough. The rest of them, I can get my vertex straight from the equation in this one. What's my vertex going to be? 4 and negative 2. Now again, at this point, if I want to, I could make a chart and get into all of this business. Or I could go back to my calculator again. Because again, if I substitute values in, I could do it that way. Because these aren't hard values to deal with. I mean, my gosh. So if I did 5, 5 minus 4 is 1. 1 squared is 1 minus 2 is negative 1. I mean, if I can't handle that stuff at this point, we're in trouble. 6 minus 4 is 2. 2 squared is 4. Minus 2 is 2. So I don't have to go to the calculator every time. But I could plug that in if I felt like it. when you plugged it in, did it? Maybe I should clear this. My two questions that most likely may have gotten you is, did you use minus or did you use the negative button? Because that makes a difference. Because when I'm doing like the x minus 4 squared, if I hit this instead of hitting this, I'll get an error message. Because otherwise, I should get a graph of my parabola that looks like this. And then again, I could so what I'll see is one thing. So that's why I try it again. I'm wondering if your memory may have gotten a little overloaded. So I'll get that. Get these plotted. And then again, my axis of symmetry, I could know that before I even graphed it. Just x equals and the x value of my vertex. So again, we've always got the calculator as a backup option, but it's not something that we necessarily have to jump to. Here, it's already in factored form. I'm going to set each of these equal to 0. So I end up with 5 and negative 5 as my intercepts. And once I have those, now to find the vertex, I'm just looking for a point that's in the middle. So I can either add those up and divide by 2, or I can just kind of work my way in. So it looks like my x value is going to be 0. But then to find out the y value, I just plug it in. Let's see, that'd be positive 5 to negative 5. So negative 25 divided by 5, bless you, is negative 5. Yeah, I'm not sure either, because 5 times negative 5 is negative 25, and then just 1/5 of it. That would do it. That's going to be another big key with some of you tomorrow. It's just taking your time and understanding that you've got this. It's just, can we keep certain things straight? Because, again, 3 different types, all 3 parabolas, but different ways of going about them. So now, bless you, before I hit up and start just bouncing around here, anybody got any specific ones yet they want? So I'll go to those first. Pretty good? Pretty good. Okay. So if we move up here, number 5. So we'll bump up a little higher so it's a little easier to see in the back. Okay, when we go to factoring, once we use the golden rule first and we remind ourselves, is there something I can take out of each term? Not this time. I go back and I start looking. So there's little hints to these things. For instance, here, there's only 2 terms. With there only being 2 terms, I'm not going to slide and divide. Not going to use the diamond. So I have to look and say, what seems to jump out at me about those 2 numbers, 64 and 25? Okay, they're perfect squares. I can square through them. So I'm going to take a look. And now again, I'm not literally going to do a square root here, because I know when I factor it, okay, what would I square to get 64? 8, my x, what do we square to get 25? Okay, negative and 1's going to be positive. Doesn't matter the order, but to get negative 25, I have to have one of each. But again, it says solve here, so I'm not just done with the factoring. I actually have to set these equal to 0 and figure out what x is. Yes. So we get a negative 5 over 8. And this time we end up with a positive 5 over 8. It won't necessarily on every single one be positive negative. So you do actually have to work them out just to be sure. But again, you can save yourself a lot of time on these just by looking for little hints and clues. Yeah, I had someone in this morning asking me about number 7. So if I slide over a bit here, hey, here's the issue we had with 7. Went through and he wanted to slide and divide. And I'm like, oh my gosh, man. I mean, you're sitting there, if you slide and divide on this, you're trying to find two numbers that multiply to 784 and add to 56. That could take a while. So I said, again, let's look for a clue. They don't have anything in common, but look at the outside two numbers. They're perfect squares. Okay. What do I square to get 16? 4. What do I square to get 49? 7. He's like, okay, but what do I figure out for the sign? Well, look at the signs that are there. They're both positive. Isn't that a lot easier than trying to figure out that ridiculous thing I was saying a minute ago? Sure. But that's only if you recognize, if you're looking for those little detail things. We're like the detail inspectors at the factory here. We're not going to let anything slide by. And since they're the same quantity, I'm just going to go ahead, and this time I'm only going to get one answer, because it's what's called a double root. What's that? Yeah, here? Yeah. Huh? No, that'd be okay. You could go to a decimal if you wanted to on this. It's still there. If I were to FOIL this out, 4x and 4x is 16x squared, and then I get 28x and another 28x. So it's still there. Anything else look like fun on page 1? 11. This will give us some good practice to when we get to completing the square a little further inside here. Some of you still are wanting to either FOIL this out or -8 first. Neither of those work. Okay, if you FOIL it out, it's just going to make more work. If you try to subtract 8, you can't. It's stuck in the parentheses right now. What do I have to do to get rid of that squared? Square root it. And here's where the fun starts. Two things I have to be thinking about. One of them is, can I break down to 24? Yes. What's it going to look like? Okay. 4 and 6, which is 2 square root of 6. But since I'm solving a quadratic, I have to have plus minus. It's not an option. It's a necessity. So once I'm rid of the parentheses, and I've broken down my radical, if I can, what's my last step going to be? Okay, I cannot combine the -8 plus 2, -8 minus 2. That radical is attached. Did I have a negative underneath my radical? No. The only time I comes into play is if I have a negative square root that I'm working with. Okay? Maybe. We're going to flip it. Let's see what else we want to play with here. Which one? 13. All right. Ooh, like the evil number 2 on the quiz. Okay. Here comes I. first thing I am going to do, before I do anything else, I'm going to pull the I out. I'm going to leave everything else alone for a minute. Because now I've at least dealt with that negative 81. So now, if the sneezes are catching, they're working their way around the room. Now I can break down what's inside the radical. So here's how this works. The I is already out there. What's the square root of 81? 9. Okay, so 9 is going to come out here with I. For the rest of this, again, we're doing old school division. My root out here is 2 when I don't see anything different. So, how many times does 2 go into 8? 4. So the whole x to the 4th gets out. I don't have anything left over. There's no remainder. However, when I get to the y, how many full times will 2 go into 7? 3. Do I have any remainder this time? I have 1 left over, so the leftover stays under the radical. It looks weird, I know, but that's the answer. That's as far as we can break this one down. Okay, 18. We can't have an I in the denominator, so let's slide this over a bit. What am I going to have to multiply the numerator and denominator by? 1 minus 4i. Because we have to change the sign of whatever's in the middle. So if it would have started at minus here, I'd change it to plus. And at this point, I've got to FOIL both the numerator and the denominator. So here's what I'll do for you. I'm not going to combine like terms right away. I want you to see what this is going to look like, and then we'll kind of put it together here. So here's what it should look like once we multiply it out. What's that? Yeah, you just would have parentheses on those too. And whether you can look at it in FOIL, whether you make little lines, whether you make a box and kind of use that as an organizational tool, any of those would be fine. But once I get here, the simplifying is going to be the big part. So my first question is, what does I squared equal? Okay, so since I squared equals negative 1, this just became negative 4 times negative 1, which is positive 4. This just became negative 16 times negative 1, which is positive 16. Now I can go to simplify. So I look up top. I've got 6 plus 4 is 10. Negative 24i, but I add 1. So it's only negative 23. And down below, I look at my I. Well, I went to that first. 1 plus 16 is 17. But negative 4 and positive 4i cancel. I'm done. The only way I would not be done at this point would be if there happened to be a number that would divide into all 3 of these. But there isn't one, so I'm finished. That's as far as we're going to get on this one. Okay, and then we might even bounce back up here, but we can bounce around some too. So let me bounce down to 23, and then we might bounce back up in a second. Because if there's one any of you see that you want on this page, just kind of keep this in mind. Well, not necessarily. It's just kind of, let's see here. Write in vertex form by completing the square. Okay, here's my first issue. Remember, vertex form looks like this. So that's the type of way this should look like at the end. That's what vertex form is going to be. So then identify the vertex. So here's how this is going to work. Instead of getting all my x's to one side, like I do when I'm completing the square, because like for instance, 21 is set up perfect to complete the square normally. When we're doing it with the vertex, we're going to add a blank on the y equals side. And instead of isolating my x terms. We're going to put them in parentheses with a blank, and we're going to let the 24 stay. But once I get it to this point, it does set up just like completing the square. I have to take my b, I have to divide it by 2, simplify that, and then square it. So just like it was in the crazy song. Half b, square half b, add it here, add it there. Okay, that's enough of the song. We're not doing anything with the square rooting yet, because we squared it, not square root. So now, on the right side of my equation, this should be able to turn into a perfect square binomial. And the easiest way to do it is to go, oh yeah, remember my half b that I simplified over here? That's what goes in. Because I could do that, or I could even factor and say what multiplies to positive 36, but adds to negative 12. Negative 6 and negative 6. So I'm not trying to solve anything here. I want these to look the same. So the only thing I've got left to do is to minus the 36 over. Okay, two ways. The easiest way to look at it is this is going to go from here to here. Whenever I make this binomial, whatever my b divided by 2 is, it's going to go here. But even if I didn't think of that, here's what you could do. Let me do a little side work here. I'm going to swing this over. I'll be back in a minute. If I'm looking at x squared minus 12x plus 36, and I went to factor, what multiplies to positive 36 but adds to negative 12? Negative 6 and negative 6. Because negative times negative is positive, and negative 6 and negative 6 is negative 12. But since these are the same, I can rewrite it as x minus 6 quantity squared. So if the factoring makes more sense to you to get it here instead of just swiping the b divided by 2, that's fine. Okay? And then lastly, it says here to identify the vertex. What would it be for this one? It's 6, negative 12. There's my two pieces. Okay. 20 who? 20. 20 or 22. Okay. 22. Okay. Now I got two of you. All right. So 22. We're going to run the same idea with one exception. When we're trying to just plain old complete the square, we need our x squared terms by themselves. So we're going to get that plus 24 out of there first. Once I do that, now we go into the mode that we were in before. Take this, and give myself a blank on each side. And the blank is going to be filled in by our negative b divided by 2. Simplify it and square it. So even if we're doing it in vertex form or regular completing the square, that's what you have to do. 64, 4. Just like before. This next term is going to be a perfect square binomial. So I can do it one of two ways. I can either ask myself what multiplies to 64 and adds to negative 16, negative 8, negative 8. Or I can just take the shortcut and steal it from when I divided my b term by 2. Let me simplify the other side. We're not done yet. No. What do I have to do now? Square root, because I got to get those parentheses out of there. So x minus 8. And I break down the 40. 4 and 10. So that ends up being 2 square root of 10. Again, the 4 breaks down, the 10 doesn't. And then we'd add the 8. Right, because to get 40 it was 4 and 10, and then we just broke down the 4. Or the 4 was 2, and then we still got the 10 left over inside. Other issues? 24. Now 24 looks bad, looks nasty, but it's not, and unfortunately I'm not going to get the whole thing on here while I'm doing this, but it's okay. The impedance in one part of a series circuit is 7 plus 4i ohms. Get that out of there. So there we go. Now we're a little better. And the impedance on the other part of the circuit is 12 minus 6i. Add these complex numbers to find the total impedance. All I'm doing is combining like terms. I'm adding 7 plus 4i plus 12 minus 6i. Adding, not multiplying. 7 and 12 is 19. 4 minus 6 is negative 2, and I'm done. Remember, it's I squared that equals negative 1, not I. I can't do anything else to this one. So again, looks complicated, but in reality, not bad. Not bad at all. Yes, ma'am. Yes. Yes, in almost every single way. 20 who? Oh, I'm typing. Wait a minute. Let's go to the next page. All right, let's see here. All right. Okay. 25. Area of a rectangle. We got length times width equals area. Now, we have options. Once I distribute, I need to get all of my terms on the x squared side, no matter what I'm going to do here. Even if I was going to complete the square, I'd have to divide. I wouldn't suggest doing that. So if we get all the terms on the x squared side, we have a choice. We can either slide and divide, like factor it, but again, I don't know how many of you want to deal with what multiplies to negative 234 and adds to negative 5. That seems kind of difficult. Well, so, if we don't want to factor, here's your other option. We're going to go to our duct tape for this section. You can do the quadratic formula on it if you want to. So you're like, ooh, so either you need to know the quadratic formula or slide and divide. Yes. So, quadratic formula, my A would be 2, my B would be negative 5, my C would be a negative 117. Watch how nice this works. It works as nice as actual duct tape does. So negative B, so the opposite of negative 5 is 5. So minus the square root of B squared minus 4 times A times C all over U times A. Got to know my formula, or this is kind of worthless still. For those of you who like to do everything at once, I'm just going to make a suggestion. This is what I'm going to do. I would just clean that part under the radical up first and try to not do this in 5 steps at one time. So if you go and you're like, okay, I suppose I'll try Hardy's way out once. He might be right every once in a while. So if I go ahead and I literally type in the part underneath my radical, I'm not even worried about putting the radical on it. That'll take care of itself here in a minute. So if I type that out, I end up with the square root of 961. You're like, oh yeah, this is looking real pretty so far. But here's where it's nice. Now I don't have to do the math. I'll let the calculator do the work. What's the square root of 961? 31. Okay. On a problem like this, when you're looking for dimensions, it probably will be, actually. So now I just got to sit here and figure out, which one's going to work for me. Well, if I think about it, it would be 5 plus 31 divided by 4. It would be 36 over 4 is 9. That's looking pretty good. 5 minus 31 over 4. Well, wait a minute. That ends up being a negative. I can't have a negative side. So I know x is 9. And then the dimensions would just be filling the 9 in each place. 18 minus 5, 9 by 13. Sweet, ready to bake a cake. Well, but we hadn't been to the quadratic formula yet either when we got there, so I was sort of holding out a little bit until we got a little bit further. Because factoring is always a good thing, even when it's with nasty numbers, but this just kind of makes life a little bit easier for us. And I knew this one was coming. I was waiting for this one to be the first one asked for. 27. 27 we will end up breaking the calculator back out. Yep. I'm going to get them both up this time. Yep, they're definitely different questions. First hour basically spent the entire time on the last page and barely got to the front. So we're going to have a lot of different stuff to work with here. So Michael throws the ball upward. The height of the ball is t seconds later is given by this equation. What was the initial velocity of the ball? Okay, initial velocity is always going to be found in front of your t term or your x term. There's nothing to calculate. You just have to know where it is. So that's going to be 45. When you get to the next part, we have choices. Because now, when I'm going through these, I want to have my answer in advance so I know what I'm up against here. I need to find, let's think about this for a minute. I'm going to draw myself a little sketch over here. What's the maximum height reached by a ball? You throw a ball up, what's going to happen after a while? It's going to come down. So basically what I'm looking at is, there's a parabola going to be working with this, and the maximum height is going to be found at the vertex. So I need to know what the vertex is. So I have to do one part, just like I did before. I have to figure out the x value of the vertex. So my x, just like it was before, negative b over 2a. So that's going to be negative 45 over 2 times negative 16, which is negative 32. So I type that into my calculator, and I get this funky decimal. That's okay. And again, we'll just round off. So that 1.4 is the amount of time, how long it will take. My seconds are going along the x-axis, how long it's going to be. My time, or my height, excuse me, how high it goes up and down the y. So I need the y. Here's your options. You can either plug 1.4 in for t on both of those, and whatever answer comes out is going to be the height. Or here's your other option. You could, if you want to go to the calculator, you could go to y equals, and you could literally type in the equation. Now again, I can't do t, I'll just do x, but negative 16x squared plus 45x plus 8. Now, again, looking at the graph is all nice and pretty. Like, Hardy, I can't even see the vertex right now. What are you doing to me? Go to your table, the second graph, and you're like, okay, now, here's something that you're kind of thinking about. This is going to come in more handy. I'm going to skip a step here for a second. When I get down to C, because you'll notice it says complete the table to show the heights. So if I look at the table, I'll come back to the last part of B in a minute. I can get those values straight from the table instead of having to plug them in. At 0, my height was 8, which makes sense because 0 plus 8. At 1, it was 37. And at 2, it was 34. I put y equals and I just plug the equation in. Now, you're like, okay, that still doesn't tell me the maximum height. How can I find that, crazy man? Here's what I'm going to suggest you do, because I still don't think this is a bad thing. I'm going to get out of here. I'm going to get away from my graph here. I think, personally, it's easier to just go old school and, come on. There we go. I'm going to take that 1.4, and I'm literally going to plug it in the equation here, and let the calculator just tell me what the answer is. There's a way to find it on the graph, but there's so many button presses with it that I think it's going to cause you more trouble than help. Ah, no. Oh, come on. Technology, again, wonderful thing until it does something you don't want it to do. And plus 8, and I will finally be to the end, and some of you probably have been waiting for me. Okay? That's my height at that time. Right. You guys are like, whew. And then the only other thing here, trying to throw a little loop at you, find the average rate of change. Find the slope. Well, find the slope? Yeah. My seconds are the equivalent of x values. My feet's the equivalent of y's. So, from 1 to 2. Okay. Take the difference in my y's. Okay. Take the difference of my y's over the difference of my x's. Now notice, 37 minus 34, okay, I have to do the same order with my seconds. I can't turn this into 2 minus 1. There, nope, that's just 37. My pen got a little dotted in there. Hey, calculator, you need to go away. Causing me problems. Okay. So negative 3 feet per second, because I know it's going downward. So it's going to be a negative slope. If it was going upward, if it was still ascending, it would be a positive slope. But that's about all I can do on that. So you'll notice I picked up some of it manually, picked up some of it from the calculator, and picked up some of it just from knowing how to find the slope of the line. So lots of little things to play with as far as that goes. Yes. Oh yeah. One way or another, you've got to be ready on this. Let me think about one thing for a minute. Maybe 6. It possibly, I remember looking at it when I looked at it last night, it possibly may be back to 30. Let me double check. Well, actually, let me stop this because it doesn't need to be sitting here wondering